Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video we will discuss question number 44 of NEET Physics paper 2016. Students, let us solve question number 44. A block, this should be black body, not block, this should be a black body. A black body is at temperature of 5760 Kelvin. The energy of radiation, so this black body has temperature 5760 Kelvin. The energy of radiation emitted by the body at wavelength lambda equals to 250 nanometer is U1. This is the energy emitted corresponding to this wavelength. And at 500 nanometer, this is lambda 1, this is lambda 2 is 500 nanometer, which is U2, and lambda 3 is 1000 nanometer, which is U3. So at this wavelength, this is the energy emitted, at this wavelength, this is the energy emitted, this wavelength, this is the energy emitted, is U3. It's given that the Wien's constant B is given as 2.88 10 to the power 6 nanometer Kelvin. Which of the following is correct? So it will just depict whether this is greater than that, or this is less than that, or some values. We know that for a black body radiation, the amount of energy emitted is correspondingly represented with this graph. That this is the wavelength, and this is the energy that is emitted. Now we know that this peak is corresponding to the lambda m, corresponding to which the maximum energy is emitted, and this wavelength, if I want to find, then I know that lambda m into t equals to b. This is from, so this is Wien's displacement law. So let us find the wavelength corresponding to which we get maximum energy emitted. This lambda m can be obtained by b over t. B is given by, in the question, 2.88 10 to the power 6. And this would be in Kelvin, this would be in meter, or this is nanometer Kelvin. This is given nanometer Kelvin. Temperature is 5760 Kelvin. Cancels out. This is in nanometer, and this 0 will cancel out. Then let us solve this one. How much we are getting? 2.88 10 to the power 5 now, divided by 576. So this is 288 and 100 multiplied, and 000 divided by 576 nanometer. So this 576 into 5, it comes out to be 2880. So this one is 5 times this, so it is 500 nanometer. So this 500 nanometer is corresponding to energy U2, and what we are getting surprisingly is that this is the wavelength and this is the energy U2, which is maximum, and this wavelength is lambda m2, which is matching with this maximum wavelength. That means, so here if I take any values, other values of lambda, this lambda is 500 nanometer at which you are getting maximum energy emitted, and other wavelengths are 250 and 1000 will be somewhere here, say 1000 nanometer, and 250 nanometer somewhere here, it will be 250 nanometer. So obviously this corresponding, this energy is U3, and this energy, suppose, I don't know, this is greater than that, I will see, and this is suppose U1. Okay, this is the energy U1. So from here it is very clear that U2 is greater than U1, and these two are never zeros. So U1, U3 0, this is not possible. U2 is greater than U1, that is possible, that is true, but U1 cannot be greater than U2, U1 cannot be greater than U2, so therefore this is the right answer to this question. Okay, thank you.